Hello friends, I am Dr. Kulkarni and this presentation deals with the sampling methods part 2. The part 1 of this presentation has been recorded separately and is available on YouTube independently. What have we learned in the part 1? Let us recapitulate what we have learned in the part 1 of the presentation. That we have learned that what is sampling, why the sampling is required. We have also learned the types of the population and the sampling method that is uh, required for that type of population. And then we discussed about the simple random sampling and systematic sampling in part 1. With this background, the lesson objectives for this lesson are that at the end of the lesson, the participants would be able to describe what is stratified sampling, when to resort to the stratified sampling, and the allocation methods in the stratified. The conceptual framework of the stratified sampling is something like this. We have a population, and herein we have, say, a prior knowledge, that is the prior knowledge that this particular population has got, say, two heterogeneous groups, that is the males and the females. These exist in any population. But as far as the variable in question is concerned, we know that the population has got two subgroups which differ significantly as far as the variable in question is concerned. In this case, the males and the females, we have a prior knowledge that they differ significantly as far as, say, hemoglobin is concerned. So in such situation, we consider the males and the female subgroups as the separate population. So we identify all the males in this population and consider them as a separate population and, say, have a separate list of the males. Similarly, we identify the females in this population and have a separate list of the females in this population. Then we treat these as two different populations as far as the variable in question is concerned, and draw a sample of males from this subgroup and sample of females from this subgroup. This we are required to do, or this we do because we know, we have a prior knowledge that this population differs significantly and has two subgroups which differ significantly as far as the variable in question is concerned. If the variable in question would not have been hemoglobin, but it would have been, say, intelligent quotient, then naturally we would have said that we do not have any prior knowledge that the intelligent quotient is different in males and females. So then for that variable, this population is homogeneous population. So therefore, we must understand that the population may be consisting of the same units, but it may be homogeneous for one variable and it may be heterogeneous for another variable. And when the variable to be studied is heterogeneous and based on that there are subgroups in the population, it is better we divide it into the subgroups according to the variable in question and treat each subgroup as the different population. And these subgroups in the population are nothing but the strata. So here we study each strata differently for the variable in question, and that's why this is called as stratified sampling. So the indication for stratified sampling is that it has to be a finite population. That means wherein the number of units in the population can be easily enumerated. So it has to be a population with a countable number of the units in the population. And it has to have heterogeneous groups for the characteristic being studied. So the groups in the population must be heterogeneous as far as the characteristic or the variable is concerned. But these subgroups in the population, there must be within group homogeneity. That is, the males should be homogeneous as far as hemoglobin is concerned, and the female population should be homogeneous as far as the hemoglobin is concerned. So we have therefore subgroups in the population that are heterogeneous or different as far as the variable being measured is concerned, but there is a within group homogeneity. Now let us explain the stratified sampling with two different examples. Suppose we are interested in a variable hemoglobin percentage in a population of say 2000 individuals. And we have a prior knowledge that the hemoglobin percentage in that population in the previous studies was 13.5 and in the female population was 9. So there is a quite a lot difference in the hemoglobin of the males and the females. And that's why we are justified in doing the stratified sampling in this case. There is another example that we want to have a study for the immunization coverage in a block consisting of certain population, and we have a prior knowledge that probably in the previous surveys we had found that the immunization coverage in the rural area was 50% and the immunization coverage in the urban area was 80%. So herein the rural and the urban population differ significantly as far as the variable, that is the immunization coverage, is concerned, and that's why this is a heterogeneous population as far as the characteristic being studied is concerned. So these are the two examples with which we will explain the method of stratification. Therefore, the information that is required is what is the total population. So the total population in this case is 1000. So suppose it is a educational institute consisting of adults and the males are 600. So that information is required. So we require the total number of units, and in this case the total number of units is 1000 and males are 600 and the females are 400. Similarly, in this case we require the total population in that block, the total population in which the immunization coverage is to be estimated. So the total population is say 1 lakh and the rural population is 70,000 and the urban population is 30,000. So the requirements that the population has to be finite, that means we know the number of the units, that is the males and the females, number of individuals, and here also the population for which the immunization coverage is to be found out is that we know. This may be children, this may be total all number of individuals. Let us say it is children, say under 2 years of age or whatever is the age. So that is 1 lakh population and 70,000 belong to the rural area and 30,000 belong to the urban area. The next step is we must calculate the sample size, and this particular problem is explained separately in the presentations on sample size calculation. So the statistician has told to us that the sample size required for that example is 200. So what is the sampling fraction in that case? Sampling fraction is nothing but the total population, that is 1000. Total population 1000 and divide the means 2000 is the sample size. So sample size divided by the total number of individuals. So 200 divided by 1000 is 20%. So in terms of percentages it is 20%. So it is 0.2. In case of immunization, the total 1 lakh in that area, and the sample size that the statistician has told us is 1000. So out of 1 lakh we want to study a sample of 1000 individuals. So 1000 divided by 1 lakh is 1%, that is 0.01. Then in this sample say of 200, how many males should be there and how many females should be there? So we multiply this number of males. This is the number of males in this population. So we multiply it by the sampling fraction. So 600 is multiplied by sampling fraction and it is 120. So 120 males would be surveyed from the male population. And in case of females, the 400 is the total number of females in that population. That is multiplied by the sampling fraction 0.2. So 80 females will be there. Now you can see here that in this population in this sample of 200, 120 is the number of females, which is 60%. And in this sample of 200, the number of females is 80%. So the number of females in the sample is 40%, and which is the number of percentage of males and females in the. So the percentage of the males and the females in the sample is therefore equal to the percentage of the males and females in the entire population. In this case, similarly, in the example of immunization, the sampling fraction is 0.01. So the total number of rural population is 70,000. So we multiply it by 0.01. So it is 1,000. 700 is the rural population to be surveyed from amongst the 1,000 individuals in the rural area in the total sample. The urban population, total urban population is 30,000. So we multiply it by the sampling fraction and it is 300. So in the sample of 1,000, we are surveying 700 from the rural area, that is 70%. And we are studying 300 persons from the urban area, which is 70% of the total sample size. So in this total sample, the strata is represented by proportionate numbers of the individuals. So this is therefore called as sampling or the allocation method, which is decided by the sampling fraction, and it is equal to the sampling fraction. In this case, the allocation is equal to the sampling fraction in each of the strata. Now, having done this, each strata is then considered as a separate population, and the required number of units are drawn from it by random sampling or by systematic sampling. And this we have already explained, how the random sampling can be done and how the systematic sampling is done. So from amongst the males, we will draw the required males, that is 120, by random. Similarly, from amongst the, we will draw 80 females by the method, by the random sampling. So for both the strata, the same sampling method has to be adopted. So we cannot do that for males we will draw by random sampling, and for females we will draw by systematic sampling. No. For each strata, the units are to be drawn from that strata either by random sampling or by systematic sampling, and that we decide. Similarly, in case of the example of the immunization, in case of immunization, we draw the requisite number, that is 700 individuals from the population of 70,000, either by stratified, either by simple random sampling or by systematic sampling. In case of urban, 30,000 individuals are there. From them, we have to draw a sample of 300 individuals. This is done either by simple random sampling or it is done by the systematic sampling. So from this rural population, if the simple random method is adopted, then for this strata also the same method has to be adopted, that is simple random. The other method by which the allocation can be done, that is we do not consider the sampling fraction, but we allocate them in equal number. Like for example, the sample size in that case was 200. So without giving any consideration for sampling fraction, we draw a sample of 100 males and we draw a sample of 100 females from the population of the females over here and males over here. So from 600 males, we draw a sample of 100 males, and from 400 females, we draw a sample of 100 females. And the method by which the 100 males will be drawn from 600 and 100 males will be drawn from females will be either by the simple random sampling or by systematic random sampling. So here the allocation is equal. In this case, the allocation is equal, and we don't give any consideration of the sampling fraction. The advantages of the stratified sampling are that using the stratified sampling, it may be possible to reduce the sample size requirement to achieve the given precision. So for a given precision, we will require comparatively less sampling size for stratified sampling. So if you are drawing it say by random sampling, and you are comparing the measurement of the same variable by stratified sampling. So for stratified sampling, we will require comparatively less number of individuals. Or it may be possible to increase the precision with the same sample size. So if you draw the same number of individuals, males and females from the population, the precision will be more in case of stratified sampling. So here is a further reading of the books for you. The Basics of Research Methodology is the book written by me, and it is available on this website. Online purchase can be made over here. And there is another book, The Basics of Biostatistics. It is by CBS Medical Publisher, and this is the website for wherein this book is available for. You can contact me at this email ID for any difficulties in this presentation or any other presentation that you have seen on YouTube. And so that finishes this presentation on stratified sampling, and thank you for the patient listening of this lecture.